I am Venkata Sai Kiran from EPH third year, here to present this video PPT on behalf of PHN 314 microprocessors and peripheral devices. I am going to present this video PPT on arranging an array of 8-bit unsigned numbers in descending order. Uh, Here, this is the algorithm or problem solution through which I am gonna achieve this solution. Achieve this. The first process is the program is to sort the array in descending order. Let's assume there are 5 numbers in this array starting from the address 3000h and going so on to 3004h. Initially we use counter minus 1 and counter minus 2 are initially these two are initialized with the size of array. Then HL pair is pointed to the starting address of the array, and in the first iteration the first number is compared with the second number, and if the first number is greater than the second number, then they don't interchange them. If the first number is less than the second number, then it will interchange and swap them. And in the next iteration, if again the first number and third number are compared, and if similarly here first number, if it's greater than third number, it won't change, and if it's less than the other, it swaps again. And similarly in the next iteration, if first number is compared with the fourth number, and if first number is greater than the fourth number, then it doesn't interchange them. If it's less than, then it will swap it, and this process continues until the counter minus 2 becomes 0. When the counter minus 2 becomes 0, the counter minus 1 is decremented, and the process continues until all numbers are arranged in the descending order. So if for example we have 5 numbers of 1 2 3 4 5, and if we check it, and every time it's different, it will swap them and it will get into the order 5 4 3 2 1. Okay, and in the next slide I am showing you the flowchart of how this algorithm works. First we'll start the program and we'll initialize the counter minus 1, and then we'll again initialize the counter minus 2, and here we'll also initialize the HL pair. Then we'll move the number from the memory location to the accumulator. Next we'll increment the HL pair to the next number's memory location, and again we'll compare the memory location to the accumulator number. And here, if the accumulator is greater than the number in the memory location, then we'll interchange, or else it will increase the HL pair. And if the HL pair increment happens, the decrement of counter minus 2 will also happen. If counter minus 2 is 0, then it will go to decrement counter minus 1, or else it will again repeat the process. And after the if decrement counter minus 1 happens, it will check if the counter minus 1 is 0. If it's not 0, again it will continue the process until all the numbers are arranged, and finally we get the array in the descending order. And here is the code through which I have achieved the descending order thing. And I have this is the step by step. First I have initialized with B, C and H, and we have changed A and M, increased H and compared M, and again we have compared M, and we have done the process as is shown in the algorithm or the flowchart. And after this I have assembled the program successfully, and here is the results, and here is the flags of everything, and here is the register numbers, and the program was executed successfully. The observations, if we here we took 3000h as 05h, 3001 as 15h in the before execution of this program, and 3002h as 01h, and 3003h as 65h, and 3004 as 32h. Executing one by one, first it will check 05h and 15h. If the first number is greater than second, it would swap them, and the process goes on and on and on. After this, the final result will be shown as here, the descending order of these numbers, that is 65h, 32h, 15h, 5h and 1h. These are the result after the execution of this of this array with the algorithm we used, and we got the results. Thank you for giving me this wonderful opportunity to share my thoughts with you, and thank you for now.